I don't know yet.
12.
Okay, so continuing on here, that's your trig, that's your derivatives of trig, some trig functions. All right, now we're going to look at one tool here for derivatives. Some more complicated, a little bit more complicated derivatives. It's called product rule. Product means multiplication. So you're gonna use a product rule when you have two functions that both have x in them and you're multiplying those functions together. Okay? So let me give you the rule here first. The derivative of, we have two functions here, u and v, alright, is
ultraviolet
u prime v plus v prime u. Okay? That's your product rule.
Didn't you already do this one?
And u and v are two separate functions?
Yeah, so let's do an example. So let's say f of x equals 3x cosine x. Okay? Now, this is different than just 3 cosine x because you have another x here. That complicates things, all right?
So does that mean you have to...
When you have x's in two places, then you're going to have, you got to do some either product rule or something else, but for now it's going to be product rule, okay? So we have two functions here, and what you want to do is label them u and v, all right? So I'm just going to take my 3x and make that u, and my cosine x and make that v. All right? And now I can do f prime of x. I got to do u prime, which is, in this case, is 3, times v the way it is. Okay, so you never do both of the derivatives at the same time. Okay? You do one derivative at a time, and the other part is the original. Okay, so 3, u, that's u, and that's v prime. I'm sorry, it's u prime and v, plus v prime is going to be negative sine x times u the way it is, 3x. Okay, and then the only thing you really need to do to simplify that is any negative signs and coefficients and x's are going to come out in front of the trig function. Okay, so this would be written 3 cosine x minus 3x sine x. So you see that you just rearrange it so that the trig function's last, and because it actually makes it more clear that way. So it's not an issue of what is actually the argument of the trig function if you put everything else in front of it. Okay, so that would be your derivative.
So if there's a negative in like any of the second part, you can just do minus.
Yeah.
So doesn't that make it 3 negatives?
Yeah.
So this is not negative. But it
Well,
would have been.
no, listen, it just makes this, it makes this whole term here, it makes this whole thing negative. No matter, okay, it's one term, so it's a negative in front of the whole thing. Okay. Alright, so that's with a trig function. You don't have to have trig functions to do a product rule. You could do, let me give you one here. Something like f of x equals x cubed minus 3x times 4x squared plus 1. Alright, so now if you have something like this, there's two ways you could do this derivative. You could FOIL this out first. You could FOIL it out first, and then you have just a polynomial, and that makes it pretty easy because that's all separate terms. Or you could do a product rule on it. I would actually recommend usually on these kind of problems that you FOIL first, but just for example, I'm going to do a product rule on this. Okay, so f prime of x. Now I have two functions that I'm multiplying together, so I want to call this one u and this one v. All right, and so u prime is 3x squared minus 3. Right? Times v the way it is, 4x squared plus 1, plus v prime which is 8x times u the way it is, x cubed minus 3x, okay? Now that could be simplified. Now notice how I used parentheses on both of these first terms, because they both have two terms in them. You got to put parentheses around that. Otherwise it's not going to be right. Now this 8x here, this could have parentheses around it. I didn't put them because you don't need them, but it's okay to put them. But it's better to put them and not need them than to need them and not put them. Okay? Yeah. All right. Okay. So then you could multiply this stuff out, combine like terms, and I'm not gonna do that right now. Okay. That's the product rule. U prime v plus v prime u. Let me do one more example. Okay. Well, I'll just do another example down here. So f of x equals, let's say, 3x squared tangent x. Alright, so let's do f prime on that. Okay, so f prime of x.
Can you give us some time to do it?
Well, I'm gonna give you a bunch, a whole 5 to do after this. So let's get these examples done. Okay, so we've got, let's label our u and v. Okay, so I'm gonna call this u and this v. And then we're going to go, u prime is what? 6x, v the way it is, plus v prime is secant squared x times u the way it is. And then let's just take this 3x squared and put it in front. So 6x tan x plus 3x squared secant squared x. Okay?
So for the product rule, we don't really have to plug anything in.
Okay, now if you have an x to plug in now is when you plug it in. So some of the problems will have
All
that.
those up here? Yeah.
Yeah.
Say that x
Yeah.
is like 2, you would plug it into each time.
Yeah, every time it works. Yeah, so let me do an example like that, and then I'll let you get the homework, okay? Okay, so let's say we have f of x is equal to
5x.
well, let's say cosine. Let's say 2 cosine x. Let me start that over. Let's say 2 sine x tan x. All right, and we want to find f prime of. Let's do pi. F prime of pi. Okay, that means do the derivative and then plug in pi for x. Okay, so yeah, so your u is going to be the 2 sine x and your v is going to be tangent x. So I've got f prime of x is equal to u prime is 2 cosine x, and then I've got my tangent x, plus v prime is secant squared x, and then I have 2 sine x. I'm going to go ahead and squeeze the 2 in right there so I don't have to rewrite that. Okay, 2 sine x. Okay, so then you would plug in pi into this. Okay, so then you would say, well, f prime of pi is 2 cosine pi tangent pi.
Wait, what are you doing there?
I'm plugging pi in for x.
Oh.
Plus 2 secant squared pi sine pi. Now that might seem complicated, but it's really not, because, well, what's cosine of pi? -1. It doesn't really matter though, because what's tangent of pi? Tangent of pi is 0. So that's out. That's 0, because tangent pi is 0. So
What's
0.
secant again?
Secant is the reciprocal of cosine. So you'd want to do cosine of pi, flip that, and then square it. However, what's sine of pi?
0.
0. So don't even do the extra work. That's 0. Whole thing's
So it
0.
just equals 0.
Yeah. Okay. Good? Let me get alright, so these, copy these down, okay? And That'll be your homework, these 5 problems, all right?
Stop recording.
So now, yeah, I will, but hold on. So look, if there's a number or a pi in here or whatever, you got to plug that in afterwards, okay? If it's left as an x, then once you do the derivative, then you're done. You just leave it. You don't have anything to plug in. It's just x, okay? No. All right.